Okay, we're going to look at complex numbers. So before I introduce complex numbers and before I get to all that, we need to understand just a little bit more and have a basic understanding of what are called real numbers or the real number system. So at the center of the real number system are what called natural numbers. Natural numbers. And natural numbers are often referred to as the counting numbers. So when I teach my daughter how to count, we're going to start with one, right? So it's going to go 1, 2, 3. And actually, the natural numbers go on to infinity. And that is the first set of numbers that we have. Now, the bigger set, just a little bit bigger than that, are what are called whole numbers. And whole numbers are the counting numbers, including zero. So the whole numbers, you get 0, 1, 2, 3, and forever to infinity. So your whole numbers, you get those, okay? So now that we can see it like this, we can say that every natural number is a whole number, but not every whole number is a natural number, right? Because 0 is not a natural number, but it is a whole number. All right, so then our next set of numbers are what are called integers. And the integers are all the whole numbers, including the negatives. So it starts at negative infinity. You get -3, -2, -1, 0, 1, 2, 3, all the way out to infinity. Right? And those are the integers. And I think of the integers as the tick marks on a number line. So if I could get a tick mark on the number line, anywhere on the number line, if there's a tick mark right there on the number line, that is an integer, right? So here we have that set of numbers. Is every integer a whole number? No. But every whole number is an integer. Did you hear how that worked? Every whole number is an integer, but not every integer is a whole number. Something to think about. Next, we're going to take a look at what are called rational numbers. So rational numbers, I think of these as fractional numbers. Okay, so it's anything in the form of a over b, where a and b are integers. I like to think about that as like 7 over 5 or 3.62. You know, anytime you have a fraction or a decimal that ends or a decimal that repeats, like 1.33 repeating, right? 1.33 repeating is really the same thing as saying 4/3, right? Where 4 and 3 are both integers. So you can have positive and negative rational numbers. Now, rational numbers have friends that are called irrational. And I don't know why they're friends. They're not. They actually have nothing to do with each other. Irrational numbers are numbers that you cannot put into a decimal, or they are a decimal that never ends and it never repeats. So think of something, a number that has a decimal that's never ending and it never repeats. You might be thinking about pi, right? Because pi is 3.14159 forever. Another one, we've seen this recently, E. Remember E, 2.71 something or other, right? And that goes on forever, never ending, never repeating. Another irrational number would be something like the square root of 2 or the square root of 7. The square root of any prime number would be considered an irrational number. Now, irrational numbers are not a part of rational numbers, right? So look at the way this diagram is set up. Natural numbers, whole numbers, integers, they are all rational. But rational numbers are not irrational numbers. So these guys have to be separate. Collectively, all of these numbers could fit somewhere on a number line, and we call that the real number system. So everything here is considered to be a real number. And that's going to be important for what we're going to learn about next.